Europe has already lived through one of the deadliest heat events in its modern history. In 2024, more than 62,700 people died from heat-related causes across the continent in a single summer. That number isn't a projection or a worst-case model. It's a confirmed count published in Nature Medicine in 2025. Now, heading into August 2026, multiple independent forecasting centers are converging on the same conclusion at once, that this month is set to extend a pattern of extreme, prolonged heat that has already broken records across the UK, Portugal, Spain, Germany, France, and Ireland this year alone. And the mechanism driving it traces directly back to something happening thousands of miles away in the tropical Pacific Ocean. The current setup across Europe centers on what meteorologists call an omega block, named for the shape it traces across a weather map, a high pressure ridge locked in place over the center of the continent, flanked by two areas of low pressure on either side, resembling the Greek letter omega. High pressure systems like this one don't just sit passively. They actively resist being pushed along by the jet stream the way weather systems normally move through in a matter of days. Instead, an omega block can anchor itself over the same region for a week or more, trapping whatever conditions exist beneath it in place. When that trapped air is already hot, the block prevents any relief from moving in, allowing temperatures to climb day after day, rather than breaking after a typical 2 or 3 day heat spell. This exact pattern has already driven high-resolution ensemble weather models to flag potentially historic mid- to upper-level thermal anomalies tracking into the 99th percentile for this time of year, according to meteorological analysis published in the past week. The regions facing the greatest risk through August cluster fairly consistently across independent forecasting sources. The Iberian Peninsula, France, Italy, and the Balkans face the most persistent threat of a locked-in heat dome, while Central Europe, including Poland, Czechia, Austria, and Germany, sits closer to the boundary zone where hot air collides with active storm fronts, meaning conditions there could swing more sharply depending on exactly where the high pressure ridge settles. If that ridge anchors itself firmly over Central Europe for an extended stretch, forecasters warn heat could spread outward from Spain and Italy toward Germany, Poland, Romania, and Ukraine. Southeastern Europe in particular, Romania, Serbia, Bulgaria, and neighboring areas, has been repeatedly flagged across multiple forecasting models as facing conditions running as much as 10 to 12 degrees Celsius above seasonal averages during peak periods this month, an anomaly large enough to push already hot summer temperatures into genuinely dangerous territory. This isn't an isolated forecast standing alone either. It's landing on top of a summer that has already produced record-breaking conditions across the continent. Parts of Europe experienced their earliest major heatwave onset in years, starting in late May, with Mora, Portugal reaching 40.3 degrees Celsius, and Kew Gardens in the UK recording the highest spring temperature ever measured in Great Britain. That heatwave arrived roughly 6 days earlier in the calendar year than the equivalent 2025 heatwave, which itself followed 2024's catastrophic summer. Soil across large parts of the continent remains exceptionally dry as a direct result of that repeated pattern, and dry soil creates its own feedback loop, since parched ground heats the air directly above it faster than moist soil would, reinforcing whatever heat dome happens to be sitting overhead. That combination of persistent drought and repeated extreme heat is precisely what has already fueled significant wildfire activity across France and other parts of the continent this summer, a pattern forecasters expect to continue expanding as August progresses. Rainfall across the continent is expected to remain sharply uneven through the month, which creates its own set of complications beyond the heat itself. Some northern regions, including coastal Norway and parts of the Baltic states, are positioned to see periods of above-average rainfall as Atlantic weather systems continue pushing through in the north. But across much of central, southern, and southeastern Europe, precipitation is expected to run significantly below average, in some areas by as much as 100 millimeters below typical levels for the month. That kind of deficit compounds an already serious drought situation, directly increasing wildfire risk while simultaneously straining agricultural production across a region already dealing with the aftermath of previous dry seasons. Here's the mechanism connecting all of this back to the Pacific Ocean, thousands of miles from Europe. NOAA officially confirmed this June that El Niño has formed, with forecasting centers assigning a roughly 2 in 3 probability that it strengthens into a very strong, potentially super El Niño by the time it peaks this winter. El Niño's direct influence on European weather is historically inconsistent. In many past cycles, Europe has seen relatively little direct impact from the phenomenon compared to regions bordering the Pacific more directly. This event is behaving differently. Seasonal forecasting models tracking the months ahead show a consistent signal of above-average temperatures, extending across Europe into September, October, and November, coinciding directly with the strengthening El Niño pattern. The specific mechanism runs through changes to the broader jet stream and global atmospheric circulation patterns that a strong El Niño event reliably triggers, patterns that don't stay contained to the Pacific, but ripple outward across the planet's entire weather system, reshaping storm tracks and pressure patterns over Europe as a downstream consequence. It's worth being precise about what is and isn't being claimed here, because this distinction matters for understanding the story accurately. Nobody is suggesting El Niño itself is new or caused by climate change. It's a naturally recurring ocean cycle that's been documented in some form for centuries. What connects this specific pattern to the broader climate conversation is a separate, well-documented trend. A 2025 study published in the Proceedings of the National Academy of Sciences found that the specific type of atmospheric pattern responsible for locking extreme weather in place, the exact omega block mechanism driving this August's heat, has very nearly tripled in frequency since the 1950s as a direct consequence of human-driven climate change. In other words, the natural El Niño cycle is layering on top of an atmospheric environment that has independently become significantly more prone to producing exactly this kind of prolonged, locked-in extreme weather event, regardless of which phase the Pacific happens to be cycling through in any given year. It's worth understanding heat domes themselves a bit more deeply, since the term gets used constantly in weather coverage, without much explanation of what's actually happening physically. A heat dome forms when a large area of high pressure traps hot air underneath it, similar to a lid pressing down on a pot. As that trapped air sinks within the high pressure system, it compresses, and compressing air heats up further, adding to whatever warmth was already present at the surface. This creates a genuinely self-reinforcing cycle. Sinking air warms the warm surface heats the air directly above it, and that heated air continues reinforcing the high pressure system holding everything in place. Clear skies typically accompany these systems as well, since the sinking air suppresses cloud formation, which means increased direct sunlight reaching the ground compounds the heating even further. This is precisely why omega blocks and similar stationary high pressure patterns produce such disproportionately extreme temperatures compared to a normal summer hot spell. Multiple reinforcing mechanisms are all working in the same direction simultaneously, rather than a single cause producing a single, more moderate effect. The human health stakes behind these numbers deserve to be stated plainly rather than left as an abstract statistic. Extreme heat kills primarily through two related mechanisms: heat stroke, where the body's core temperature rises faster than it can dissipate heat, overwhelming the organs, and cardiovascular strain, since the body's attempt to cool itself by pumping more blood to the skin places significant additional stress on the heart. Elderly populations, young children, outdoor workers, and anyone with existing cardiovascular or respiratory conditions face dramatically elevated risk during events like this. The 62 out of 700 deaths recorded across Europe in 2024 weren't evenly distributed either. They concentrated heavily among these same vulnerable groups and heavily in the specific regions, southern and southeastern Europe, that current forecasts suggest will again bear the brunt of this August pattern. Nighttime temperatures matter just as much as daytime peaks in this equation, since the human body needs a period of cooler nighttime temperatures to recover from daytime heat stress. And one of the specific concerns forecasters have flagged for this August is cities across the Mediterranean holding overnight lows above 20 degrees Celsius for extended stretches, denying residents that critical recovery, window night after night. Looking beyond August, the pattern shows some meaningful shifts as autumn approaches. September is expected to remain warm across much of the continent, though forecasters anticipate more frequent Atlantic frontal systems beginning to break through, some carrying the remnants of tropical storms and hurricanes that have tracked across the ocean. October looks broadly similar, particularly across eastern portions of the continent, with a slightly milder signal emerging toward the north as well. Moving into early winter, the picture shifts again. Forecasters expect conditions to remain relatively mild as the transition out of autumn continues, but with a notable change toward wetter conditions, developing across more locations as El Niño's influence continues asserting itself through the colder months. None of this means every single location across Europe will experience identical conditions throughout August. Weather remains genuinely variable, even within a broader pattern like this one. Parts of Scandinavia and portions of the British Isles are positioned to see near average or even below average temperatures at various points during the month. And periodic Atlantic frontal systems are expected to occasionally break through the ridge and bring temporary relief to some regions, even within the broader hot, dry pattern dominating the continent overall. But the consistent signal across independent forecasting models, using different data sources and different computing approaches, all pointing toward the same broad outcome for Central, Southern, and Southeastern Europe specifically, is exactly the kind of high-confidence convergence that meteorologists take seriously rather than treating as a single outlier forecast. It's also useful to place this year's pattern against the recent historical record because the trend across just the past 3 summers is difficult to dismiss as ordinary year-to-year variation. 2024 produced Europe's deadliest heat event in the modern record, with peak temperatures reaching 46.8 degrees Celsius in Cyprus and confirmed heat-related deaths exceeding 62,700 people. 2025 followed with its own significant heat waves, including new June temperature records broken across Bosnia and Herzegovina. Now 2026 has already produced the earliest major heat wave onset in recent years, arriving in late May rather than the more typical June or July window, before this current August pattern has even fully developed. 3 consecutive summers producing record-breaking or near record-breaking extreme heat events isn't proof on its own of any single specific cause, but it is exactly the kind of accumulating pattern that gives the atmospheric blocking research we mentioned earlier its practical weight, an observed trend of increasingly frequent locked-in weather patterns showing up in the real-world data year after year, not just in a modeling projection. There's also a broader atmospheric mechanism worth understanding, connecting the Pacific Ocean's El Niño state to jet stream behavior over Europe specifically. The polar jet stream, the fast-moving river of air high in the atmosphere that generally separates cold polar air from warmer air to the south, doesn't behave independently of ocean temperatures thousands of miles away. Changes in Pacific sea surface temperatures during a strong El Niño event shift the pattern of atmospheric heating in the tropics, and that shift propagates outward through a chain of atmospheric responses that meteorologists call teleconnections, eventually influencing the position and strength of the jet stream over the North Atlantic and Europe. A weaker or more meandering jet stream tends to allow high-pressure ridges to become stuck in place for longer stretches, precisely the omega block pattern driving this August's forecast, rather than being swept along and replaced by the next weather system within a few days, the way a more vigorous, fast-moving jet stream would typically allow. The same strengthening El Niño event driving unusual Pacific Ocean behavior this year is now showing up as a measurable influence on European weather patterns heading into autumn and winter, layered directly on top of an atmospheric circulation pattern that's already become significantly more prone to locking extreme heat in place than it was just a few decades ago. A like and a subscribe genuinely helps more people see this kind of breakdown, and this is exactly the sort of slow-moving, well-forecasted story worth continuing to track as August unfolds. The practical reality for the weeks ahead is straightforward even with all this complexity underneath it. Regions across the Iberian Peninsula, France, Italy, and the Balkans face the most persistent risk of extended, dangerous heat through the first half of August specifically, with the potential for that pattern to intensify further or shift eastward toward Romania, Ukraine, and neighboring areas, depending on exactly where the high-pressure ridge ultimately anchors itself. Dry soil and expanding drought conditions mean wildfire risk continues climbing right alongside the heat itself, a compounding hazard rather than 2 separate problems. And underlying all of it sits a strengthening El Niño event, confirmed and actively developing in the Pacific, whose influence on this specific pattern is expected to persist well beyond August, continuing to shape European weather through autumn and into the coming winter. The agricultural stakes underlying this pattern deserve mention too, since they tend to receive far less coverage than the immediate heat and wildfire risk, despite carrying serious longer-term consequences. Extended drought combined with repeated extreme heat directly threatens crop yields across some of Europe's most agriculturally significant regions, including parts of France, Spain, and the broader Balkan agricultural belt currently facing the sharpest precipitation deficits. Reduced soil moisture during critical growing periods can suppress yields for staple crops months before any harvest data actually confirms the damage, which is part of why agricultural forecasters and commodity markets already begin factoring seasonal outlooks like this one into their own planning well before the season concludes. Farmers across the affected regions are managing the same underlying pattern in real time, adjusting irrigation schedules and harvest timing against a backdrop of soil conditions that current forecasts suggest are unlikely to meaningfully improve before autumn brings a genuine, lasting shift in the precipitation pattern. This is a genuinely well-forecasted, high-confidence pattern, not a single alarming headline pulled from one source. Multiple independent meteorological organizations, using separate models and separate data, are converging on the same broad outcome for the weeks ahead. Thank you for watching, and I'll see you in the next one.